Well, it's Sunday, and usually we do Sierra Hotel 1 Tango Sunday, but this is anything but. This is supposed to be a new old stock in the box, Midland 77 805. And this has come from a customer. And we'll try and open the brown paper. Now, this gentleman has paid more than three figures for this, as in £100 and something. And he has paid twice the wholesale cost when these were around at the time. And the person who had these around, I said I would pay three figures, but that's where it would end, because we've not actually had one. We've had the sets, but we haven't had the rest of it. So, if I can actually get it out of its nappy. Just like current new sets, it's probably doing 2.5 watts. Nothing's changed, you know. I don't think he's included everything. The box isn't pristine. Now, I did ask him to send that if he wanted to, the case that is, because I said if he wanted us to, we'd do a field test with it. Because we never field tested one of these, and I think everybody's interested as to how they actually work when in actual use, rather than just doing an on-the-air test from the bench here with the roof aerial. So, which side's it going to be? It's going to be this side. I'll tell you what, before we open it up, I think we best go through a performance check. So we'll plug it in with the cigarette lighter. It says 13.2 volts. We're going to probably run it at 13.8. Now, these don't have an internal loudspeaker, and so we have to plug in the proprietary speaker mic and switch on. Right, let's put picture in picture on. It's a blank piece of paper. I think it's the D version rather than the UK. Can't see the writing. It's a D, yes. It's got a extra chip in the receiver and does away with quite a few transistors and things. There's rumours on which one's better and all that, but as a service engineer, I can't say that I've seen more of one in for repair than the other. I've probably seen more UK ones in existence. So we're on channel 20. Let's see what the transmit is doing. So we'll start on the 3 watt scale, full scale deflection if we're getting 3 watts. And I've got the tannoy system on the scanner, which is going to cause us some feedback. So it's doing 2.7 watts. Deviation. Modern sets come out about 1.4. Let's have a look. Wallow. That's about right. So it's probably been adjusted. Not bothered about what low power does, but we will check that. Let's flip the switch. 170 milliwatts. Should be 400 milliwatts. Right, receive. And before we do that, how on frequency is it? Let's move the camera over. Some 79125 2779051. So it's dropped with age as they do, but that is still in spec, but I will alter it anyway, of course. So I'll receive. Let's go over to the synod meter, and so she's actually on. And we're hearing 0.3 microvolts there, so that's quite good. So for 12 dB synod, I'll show you the attenuator. The 1 and between 5 and 6, so it's 0.55. RX 0.55 microvolts. For 12 dB synod. Sometimes on specification it says noise quietening, which is the same thing, or signal to noise plus noise ratio. Right, so we'll get straight into this and we'll see what we can do with the transmit when I find my notes on what to adjust. Okay, so that we've not seen the D version ever before of this. Certainly not made any notes, don't have a circuit diagram, don't have anything on the D version. It's much, it's obviously the final one they did. That's a factory fitted crystal filter. So, not sure why anybody would say it could be inferior, or perhaps they say this is better, I don't know. I don't know what people say, because I take no notice. What we find is what we find on the test instruments. So, we don't know what all the coils are. We do know what most of the preset designations are, RV3, RV1. So, the fact that this wiring goes to that switch, chances are that's going to be low power. In fact, I can just turn that a little bit and we'll just see. Do you know what, I'm going to have to turn this tannoy speaker off. So we're on low power, let's see whether that adjusts it. No, it doesn't. Oh, perhaps it isn't adjustable. Oh well. So presets, that's going to be deviation surely. There's going to be squelch and S meter, one of those. Should expect the low power and TX meter to be the other. Oh well, anyway, we'll work through this. We'll work through the transmitter and see whether we get anything greater than the 2.7 watts it's come with. So it's now less. So one of those was high power. That is sealed, and I'm struggling with that. Use a more suitable tool. Aha. So this is high power setting. So I'll pop that up to full just for now. We will reset that. So I'll make sure RV4 it says high power. So now we'll set the transmitter up. So we're now at 3.4 watts. I'll tell you something else we'll do, although this doesn't affect it. I'm not showing you the right. I'm not showing you the right thing anyway. Let's put it on frequency. There you go. So there we are, 3.5 watts. Let's just pull that up. So that was at peak. That's at peak. That's at peak. That is possibly the trap for 55 megs, because it's having no effect on the power. So I'll put the spectrum analyzer on. So we have a radio that's 3.5 watts at 13.8 volts. And that's it. That's better than 2.7. Of course it is warm now. Right, let's just put that spectrum analyzer on. I've pinched the lead for a different instrument in the other room, so we'll come back to that. Just out of my own interest, which is is that the meter? It is. And you're supposed to set it on low power so that it shows 1 bar. But it's also supposed to do more power than 170 milliwatts. Okay, so that is meter. See, back in those days you had real meters, not fictitious bar graph transmit lights, which is all a lot of them are today. Let's look at deviation. So that's covered those two. They're the only two I've fiddled with. Chances are that's going to be deviation. Let's get the little oscillator out. It's not that. There's a big resistor there, that could be low power. So we've got to look at what else is in that part of the circuit There's always a possibility that is it, but it isn't. You really wouldn't expect that one to be it, but it is. Testing 1, 2, wallow. There we go. I've not really had to touch that, but I have just taken it up a fraction. So that's deviation. So that's got to be surely low power. Let's go back to the power. It isn't. Well, that couldn't be power. No, so it's probably, the power must be preset. So we're going to have RX meter and we're going to have squelch. And that's all we've got left. Right, we'll look at the receive then. So we'll go over to the cyanide meter. Let's put it to about 4 decibels and see whether we can get any improvement on that. The answer is that's actually a fraction better. As I've said time and time again, they probably have 20 seconds at the factory to do this. Once it hits that minimum accept mark, off on the conveyor belt it goes. Whereas I can spend some quality time doing this. We knock the signal down now. Let's go back to that one. Let's put a big signal on for that one. And a smaller signal. I think that's about where we are. Look at the detector. We'll put the oscilloscope on, switch to the oscilloscope, and put the bench light off. Just set the volume so we get a sensible trace. And it's just audio we're looking at, and we're looking for maximum recovered audio. That oscilloscope is simply across the loudspeaker terminal. It's just only needs to be a 1 meg oscilloscope, it's nothing clever. That's a 10 meg one. That was already spot on. It's always best to check. Right, we'll turn the oscilloscope off and we'll go back to the cyanide meter. So we've done those 4. There's no hidden ones I haven't spotted. There are less stages in this with it having the chip there. So I've never seen one this version. I've seen the baby Midland later version, the D, but not the 805. So let's see what we've now got. It is better. So that's our 12 point. What is it now? So if you remember, it was 0.55. It's now. Let's go to the attenuator. So it's still on 1, and now we're at 3.8. So now 0.38 microvolts. For 12 dB cyanide, so that's a worthwhile improvement. So it's now 27,79126. That was fine. That was fine anyway. 2.7 watts. So, like I said, I'm going to look at that on the spectrum analyzer, but I'll just have to get a lead from the other room. What we'll do is just go and look at what power it's doing now. It's cooled down a fraction, which was really clever because it's on low power. 3.5. I'm not going to push the volts up to see at what point it becomes 4 watts because it's customer's set, so we're not taking it beyond 13.8 volts. Now 3.5 watts. Remember, these are the watts I'm showing you are on a commercial test instrument. If we got out the Zetagi Good Buddy meter, which I think is up here. Yep. Now then, I need an adapter. It's the Bench's BNC. Yes, I'm going to have to get an adapter as well to show you that. But we'll use the Zetagi meter. So don't think you're short-changed. It's the Marconi test set I'm using is selective to some degree. It's in bands, and it's basically looking at 10 to 24. It's looking at 24 to 33 megs. So it's going to ignore spurious emissions. Whereas the radio may be giving unwanted power on other frequencies, which we're going to look at with the spectrum analyzer. So I'll get up and I'll get I've also looked at the clock. I've got a church service this afternoon. It's London Thorpe's Harvest Festival, and I'll go and get a adapter and a BNC lead for the spectrum analyzer. Okay, let's look at the Zetagi meter. So we know it's doing 3.5 watts on the Marconi test set. Let's see what it's doing on here. And the answer is about 4.2. Yeah. So it's 4.2 Zetagi watts. I've thought of another experiment. I saw on eBay somebody selling, I think it was a Uniden 100, and allegedly it's 6 watts output or 7 watts output or something, which, legality aside, with the limit being 4 watts, legality aside, I'm not even sure that I've seen that kind of power coming out of those sets. But he's showing it on his photo into an aerial. We don't put it into an aerial, he's put it into a dummy load, because if the SDR was absolutely 1-to-1, you can't show power. It's not going to read right. So I've now connected our base station aerial, which is about let's see what the SWR is. So we'll go into SWR. We'll key up. There we go. SWR is about 1.6. Now then, let's go into power and see what this radio does into my aerial. Oh, it does 6 watts. Whoa, this radio is doing 6 watts. No, it's not. It's doing 3.5. See the kind of bull that people come out with? Just thought I'd get that one in. We're going to do a thing on 28 megs. I'm doing it on 28 megs because I can do my ham radio A license allows 400 watts. Not that I don't think I've got anything which does more than 55. And what we're going to do is going to take a 28 meg FM radio to either on the bench or to Scratchy Corner and I'm going to change the power levels and just show the difference in signal. When we get to a scratchy point, I'm just going to have Mr. Chippy park up, and I'm going to show what it works like at 1 watt and 2 watts and 3 watts and 4 watts and so on, just to show right up to 40 watts, just to show how little difference power actually makes. You actually have to double the power to... No, you have to square the power, don't you? Something like that. I think, if I remember rightly, I'm telling you a whole load of bull. If I remember rightly, to double the range from 4 watts, you'd have to go to 64 watts. Right, so we're now going to look at the spectrum analyzer. I'll just loosely couple that somewhere in the vicinity. I think that will do. That's going to probably pick up. Yes, it is picking up. And I'll put the camera on that. There we go. So we're looking at, what I'm looking at is, I'm looking at this harmonic here, and I want that to be at minimum. I adjusted that coil and I might not have been supposed to. Let's do I'm going to do a count on that. So 55.54 megs, minus 54 dBm. By the way, there isn't supposed to be a core in that, just in case you think it's missing, it isn't. Right, so that's just checked the harmonic. So back to receive. S9. So on a CB radio in the UK, it's 100 microvolts for S9. So one of those two presets is going to be that. It's that one. So it's plus 30 at the moment. It's just there, S9. So now if I increase the signal on the signal generator, it goes up, and if I decrease the signal, of course, it goes down. Like that. So we now know that RV1 is S meter. So that has to be squelch. Fingers crossed it has to be squelch. Looking at the time, I've got about 45 minutes, so we should be alright. So I said the customer would like us to do a field test with this. Mr. Chippy's back Monday night. I don't think we'll get the field test in Monday night. Customer wants us back by the 9th. He's on holiday. So we'll probably do it Tuesday. And do the on-the-air test Monday night if Mr. Chippy's back in time. So I think that's what we're going to do. So on-the-air test will be from the bench as usual, and he'll drive away. And the field test will be with the body cam, and he'll go for a walk with it. I'm not expecting it to work as well as the realistic sets. I know they're 3.5 watt radios too, because they have the ground plane onto those metal side panels as a range boost thing, and it does work. I know it sounds like sales bull, but it does work, and we do get 6 miles repeatedly on the 1001s and 1005s, and even the 1.5 watt 1002 we've had that range out of. Not every time, but we've had that range out of. So I'm not expecting this to work quite as well. I think we're going to get 4 miles. We'll see. So that brings us to squelch. So I'm going to put the squelch to full. That's squelch at full. And I want this radio to open up at 100 microvolts S9. So 3, 10, 30, 100. It does. It's exactly right. Now, I don't need to adjust that, but I've got to adjust it, haven't I, to prove that that preset is the squelch. Well, it's not doing anything. Ah, but it's now not opening at 100 microvolts. So it is the squelch. So I've set it back where it was. Good. We're done. So low power is not adjustable. Now, because we've increased transmit from 2.7 to 3.5 watts, I would now expect low power to be greater than 170 milliwatts. So let's have a look. So we'll just go back into transmit. Just put that meter up. And we're on the 3 watt scale. So transmit low power is 170 milliwatts. It's actually no different whatsoever. Now, the other thing I'm just going to do is turn the power down on the power supply. So we're at 13.8. We just want to see what happens when we go down to 12 volts. So let's look at this. So at the moment, we're at 3.5 watts. We'll turn it down. Power supply to 12.8 volts. That's fully charged 12 volt battery. Now just 3 watts. And let's go down to 11.8 volts. So we're starting to get a flat battery. Is 2.5 watts. So it came in, this radio came in doing 2.7 watts, and that would now be achieved on 12.5 volts. Now we're going to go back to 13.8 volts. I'm going to take it a fraction beyond that. So my car charging 14.4, 3.8 watts. I'm not going to take it further than that, it's not my set. There we go. So it's quite safe to use in a vehicle. It's not a 12 volt radio, it's 13.2 volt radio. So there we are, they're the figures. So we have managed an improvement. I'll put the lid on. And what it has helped us to do is, I've now seen this version and can see it's crystal filtered, unlike its predecessor, and I have no reason to doubt that it doesn't work very well indeed. What we'll just look at, which I've just kind of forgotten, is we'll look at where the squelch sensitivity is. So at what point does the squelch actually come in at minimum? Because on an FM radio, that is all important. We've had some lousy squelch on some otherwise good radios. One of the team models comes to mind. Like 10, I think it was 10 microvolts to open the squelch, and things like scratchy corner just are not going to work. So we'll just pop these screws in. So at least it's done, and if the customer said, look, I want it back, it can go straight back. But he did say, as long as Mr. Chippy doesn't bend the pristine aerial. Right. I've just seen one of those aerials go through on eBay for about £34. So we'll turn the signal generator off. I'll put that onto the attenuator control. So we're now parked at 0.3 of a microvolt. The red light shows we're in standby. So we'll set the squelch to threshold, switch the signal generator back on, and 0, let's see, when does it come in? it comes in. Wow. I'm going to have another go at setting this squelch. That was lousy. It was nearly 2 micros. Try again. Not that you should have to be really finicky on a squelch. Okay, try again. Okay, that's better. It's coming in at 0.8 of a microvolt, and it's disappearing off at 0.2 of a microvolt. So we'll turn the squelch down, and we can hear the radio at what? So that's now 0.3 of a microvolt, 0.25, 0.2, 0.15, 0.1. Here's about 0.09 of a microvolt. So it's nice and sensitive. We've brought it up with the 12 decibel cyanide. I'll just look at what it's doing for 20 microvolts just for a laugh. And for 20 microvolts, it's 0.95 of a microvolt, so that's fine. So with that, we'll pop the aerial off. The aerial, that is, to the test equipment. In fact, we'll turn the test equipment off. Turn the squelch up a fraction. Remove the extension speaker. Turn picture-in-picture off. And the spectrum analyzer so that its fan's not running. And we'll plug it into our Antron 99 roof area with a kink in the end. We'll have a flick round. It is 2:45 on a Sunday afternoon. So we're 35 miles from Nottingham, 32 miles from Lincoln, 28 miles from Boston. So all this is coming from those kind of cities. 19er Roger. When we got a Roger the other day, it turned out to be Quotages 4 miles away. I didn't realise it was him. They just sit on 19, don't they? I don't get it. Right, okay, so we'll await Mr. Chippy coming on Monday. I'm going to have to take that off the bench in the meantime, otherwise we'll have... Actually, I can do an audio job. We've got an audio job. I can leave it on the bench. Now, this has skipped. There is a realistic 1005 handheld already in. I've only pushed this through because the customer wanted it back for his holiday. There is a Sakanaki Zaki deviation meter coming. So thank you for watching the Midland 77805D UK, which is about 1995, about the final ones they ever did. It's not got, has it got a date on the back? No, but they shifted production to Thailand by then. Thanks for watching.